Hello Year 9. So today it's the final unit of the motion topic, and we're looking at analysing motion graphs and how to use that information on the graph to answer questions. So today, instead of a SAM learning test, there is a worksheet that is attached to today's lesson. What I suggest you do is go through the slides and then at the end attempt the questions. I will then email you the answer grid. You can mark it and give yourself a grade. So here we go. So 1 to 10 in the margin. Can you just quickly pause the slide and answer the following 10 questions for me? So here are your answers. What we've got here is a whole range of different equation triangles that you need to be aware of. So you'll notice at the top of the second triangle we've got S, which is displacement or distance from the origin. Okay, mark yourself out of 10. Thank you. So calculating speed and velocity. Speed is measured in meters per second, which is distance over speed, or distance over time, or speed times time, depending which way around you make it. Okay, have a go at calculating the following answer. So 100 meters divided by 10 gives me 10 meters per second. Second question, Porsche travelling at 40 meters per second for 2 minutes. How far did it go? Distance equals speed times time. Therefore, 40 times 120 gives me 4,800 meters. Okay. You'll notice that displacement is equal to S, and people often get this confused to speed, right? The acceleration of something tells you how quickly the speed is changing. We can say acceleration is the amount of speed changes per second. Acceleration, change in speed is meters per second over second. Therefore, acceleration is meters per second squared. You'll notice this funny little triangle, and that triangle is called delta. And that delta is what we use to represent, it's the Greek letter to represent change. And V is final velocity, U is initial velocity. So again, this is an equation that we haven't really talked about before. So we talk about V minus U, which will give me my change in speed or my change in velocity divided by time. As it is just a simple equation, you can just push that into an equation triangle as well to rearrange it. So let's have a go at number 1. The Ferrari was travelling at 20 meters per second behind a lorry. It pulled out to overtake and accelerated 4 meters per second for 2 seconds. What is its new speed? So acceleration times time, 4 meters per second times 2 equals 8. We have to, new speed is old speed plus changing speed, therefore it's 28. So here we've got some motion represented on different graphs. Firstly, what I'd like you to do is draw these out so that you've got a note of them. You're often asked to compare velocity time graphs to distance time graphs, and it's also an area of huge confusion. So the first one we've got, okay, just to make sure that you're aware of this, time always goes along the bottom, and either distance or velocity go up the side. The first one we're going to be looking at for the 3 types of motion is stopped or stationary. And you'll see on the first graph, the distance time graph, doesn't matter where we are, we then plateau, we flatten out. Whereas on a velocity time graph, we go back to 0. There's the next one, which is constant velocity. We have this exponential rise, and distance is directly proportional to time. And we see this gradient. Now, the gradient obviously is also equal to speed. Whereas velocity, constant velocity is a plateau. Okay, there's no gradient in it at all. Constant acceleration. So we have this could be a curve on distance time graph, whereas it's a straight line on velocity time graph. You'll often be asked to, given the blank axes in a test, and asked to sketch what you think is happening. The gradient in a distance time graph represents velocity / speed. When you think about the gradient in a velocity time graph, it represents acceleration. So if it's not speeding up, then there is no gradient. So the area under the graph on a velocity time graph is equal to the distance travelled. So here we're going to got a worked example, and we're looking at a distance time graph and the object moving with changing speed. Now, this distance time graph, we need to work out the gradient of the triangle. In order to do that, we do height divided by base. So it doesn't matter how we draw the triangle, whether it's smaller or larger. However, we choose a point when we draw a triangle around that. We draw a tangent to the line. So as the gradient increases, so is the speed of the object. You can find the speed of the object at any point by drawing a tangent to the line at any point. And the tangent to the curve is the straight line that touches it but does not cut through the line. So it's really important that it is right next to that line, but it doesn't go over the line. So looking at the graph below, this is a velocity time graph. So we're going to break up the graph into 3 parts to answer the 3 questions. Firstly, what is the acceleration from 0 to 15 seconds? So we need to look at the change in velocity, which is from 0 to 150. So change is v minus u, which gives me delta change, which is 150, divided by 15 seconds equals 150 divided by 15 gives me 10 meters per second squared. What's happening at 50 seconds? Well, what is actually happening? At 50 seconds, his speed becomes constant. His velocity becomes constant. And that is likely due to the fact that his parachute was open and therefore he's decelerating. Number 3, how far did he fall altogether? Under the graph, area of the graph, you do 50 times 150 plus 50 times 15 gives me 8,250 meters. So there is a student worksheet that's associated with this, and we need you to have a go at it. So what we think is that I will finish here. There is no SAM learning. The student worksheet is attached. And you need to work through the worked examples using today's sheet. Now, tomorrow's activity is a test. So it's really important that you spend any time extra today's lesson going through the material and ensuring that you've understood both the forces between objects and the motion unit. Take this opportunity as well to reflect on your rag sheet and see how you've understood. Thank you. Bye.